Tutorial 5. First question. Debug the selection sort algorithm with an arbitrary 5 elements list on PyCharm. One of the first debugging method of every computer programmer used, I believe, is print method. Today, in all integrated development environments, there is a debugging option. In PyCharm, the debugging button is next to Run button. But before clicking on debugging, one should define a code to execute and one should define where the program needs to be stopped. This is done by breakpoints. So this is my code. I want to execute selection sort of this list and I set my breakpoint at the beginning of the first loop. Now I can hit the button, debugging button, and by clicking on step over button, I will investigate what my code will do at every line of my code. I hit I is 0, J is 1. Now it will make a comparison between jth element and the 0th element. So first element and the 0th element, it is true. 2 is less than 9, then it will swap. It's done. It increments j by 1. It will compare the 0th element and the second element, and it does nothing. It increments j by 1. It makes the comparison. It does nothing. It increments j by 1, and now it will compare 2 and 1, and it will swap. Once it's done with the second loop, it increments I by 1. I is 1, J is 2. It compares the second element with the first element and it swaps. It increments j by 1, compares third and first elements and it swaps. It increments j by 1 and it swaps. Now it will increment I by 1. J is 3. It compares third and second element. It swaps. It increments j by 1. It compares second and fourth elements. It swaps. When it is done with the second loop, it increments I by 1. It will compare third and fourth element, 7 and 9. The comparison is true. It swaps. It increments j by 1 and goes out. It increments I by 1 and similarly it goes out and it returns the S list, which is 1, 2, 4, 7, 9, an ordered list of the initial S list. Second question. Create a function log2 that takes one argument, x, a positive float, greater than or equal to 0.5, and compute two-based logarithm of the argument with a precision of 0.01 using divide and conquer method. First, let me explain the scheme. First of all, we have to find an integer n for which 2 to the power n is greater than x and 2 to the power n minus 1 is less than x. Once n is identified, set n as upper to upper and assign n minus 1 to lower. compute the average of upper and lower and assign to k, then compute 2 to the power k. If 2 to the power k is greater than x, then we will deal with the left part of our scheme. Do not touch lower, but assign k to the upper. Compute the average of upper and lower and compute 2 to the power k. If 2 to the power k is less than x, then we will be focused on right hand side. Do not touch upper. Assign k to lower. Compute the average of lower and upper. Compute 2 to the power k and keep going on until 2 to the power k minus x or x minus 2 to the power k is less than or equal to 0.01. In this part of the code, first of all, we will find the first integer for which 2 to the power n is greater than x. So, we will assign 0 to n and while true, compute 2 to the power n, and if 2 to the power n is less than or equal to x, increment n by 1. Otherwise, it's done, so we will break the while loop. Set or assign n to upper, assign n minus 1 to lower. Then we will start another while loop. Compute the average of upper and lower. Compute 2 to the power k minus x and compute x minus 2 to the power k. If one of them is between 0 and 0.1, then it's done. Return the value k. Otherwise, if 2 to the power k is strictly greater than x, assign k to upper. If 2 to the power k is less than or equal to x, in this case, lower is equal to k. To test my code, I create a list called test with some particular floats. For example, a negative float, a float which is less than 0.5, 0.5, a float between 1 and 0.5, 1 to 8 and 56.32. And for every element in my test list, I will compute log 2 of n. Minus 10 is less than 0.5, so it returns none. Similarly, 0.04 is less than 0.5, it returns none. For 0.5, it is almost minus 1. For 0.8, it is minus 0.31. For 1, the logarithm is 0. For 2, the logarithm is 1. For 8, the logarithm is 3. And for 56.32, the logarithm of 2 is 5.81. My algorithm will not work for floats between 0 and 0.5. So it's up to you to overhaul my code to include floats between 0 and 0.5. Third question. Create a function called insertItem that takes two arguments, a sorted list and the item, and insert the item to the appropriate position using divide and conquer method such that the list is still sorted. First of all, we will create a helper function concatenate lists which takes two arguments left and right and concatenate right to left. In the main function insert item which takes two arguments sorted list and item, we will use a recursive method. So in the first part we will define the base case. If length of sorted list is strictly less than 2, which means that if the sorted list has one element, then compare the item with this element. If the item is strictly less than this element, then assign sorted list to right, create a new list with the item and assign it to left. Otherwise, assign sorted list to left, create a list with the item and assign to right, and at the end call the helper function concatenate lists left and right. Otherwise, first of all, find the mid index of the list, of the sorted list, then assign right half of the list to right, left half of the list to left, and check if the item is strictly less than the mid element of the sorted list. If so, keep the right as is and recursively call insert item with left and item and assign to left. If the item is greater than sorted list of the middle element, in this case, keep the left as is and recursively call insert item with right and item and assign to right. And at the end, recursively concatenate lists. In order to check my code, I will generate a random integer between 0 and 105, print this integer, and then I will call my function insert item with a sorted list and g and print the result. The item to insert is 36, and when I look at the result of my code, 36 is at the right position. Homework. First question. Create a function called square root that takes one argument, x, a float greater than or equal to 1, and computes the square root of x with a precision of 0.01 using divide and conquer method. Second question. Create a function search item that takes two arguments, a sorted list and an item, and using divide and conquer method returns the index of the item. Third question. Improve the selection sort algorithm which avoids any non-value adding computation. In other words, breaks the loop if it is done. Create a function called isPrime that takes one argument, x, an integer, and computes if x is prime or not, and return true or false. First, find prime numbers up to square root of x using sieve of Eratosthenes, then compute if x is divisible by these prime numbers.